Okay, so we're going to start off with this first problem, and this is really just a reminder more than anything else that you need to be able to take each of your 6 trig functions and know what the graphs of those trig functions look like. You need to be able to label the tick marks on both the x and y axis for each graph, and you need to be able to tell me what the period and the amplitude is if the amplitude exists for that particular function. All right, so I'm going to start off with the sine function. And I'm just reminding you here that your sine function, f of x, is equal to sine x. All right, and so I'm going to draw a graph, and I'm going to mark off the 5 key points. So remember your 5 key points. You have 5 tick marks. You have one at 0, which you're not really going to be able to see that one. You have the next one is at pi over 2. The next one is at pi. Then we have 3 pi over 2. Then we have 2 pi. All right, so you want to remember that those are your 5 tick marks on the x-axis for the sine graph. On the y-axis, you need to mark up to +1 and down to -1. And remember now, when we learned to draw these graphs, we said that we would have on the sine function that it would cross the x-axis at the 1st, 3rd, and 5th points. So you will have a point here, here, and here. 1st, 3rd, and 5th are the x-intercepts. Remember, your second point goes up to 1. And your 4th point goes to -1. All right, and then I'm going to connect, keeping in mind that you want to be able to do this really quickly on the test. If you need a graph of the sine function, you want to be able to come up with that graph very easily and quickly. All right, so I'm going to pair that up with the cosecant function real quick for you, and then we'll move on to some of the other ones. All right, so on the cosecant function, remember that cosecant is 1 over sine. So it is going to have asymptotes in the same places where the sine crosses the x-axis. All right, so I'm going to put my same 5 tick marks on this graph. So I've got 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now again, asymptotes occur where the sine function is equal to 0. So we are going to have an asymptote at the y-axis. We're going to have an asymptote at the 3rd point and one at the 5th point. All right, and then we said that you should go ahead and draw your sine function inside this graph. Okay, so I'm going to real quick sketch my sine function in here. And the reason that we do that is, remember, the cosecant is sort of a mirror of the sine. And so on the between the first 2 dotted lines, the cosecant graph is going to come down. It's going to hit that same point at 1 and come back up. And between the last 2 dotted lines, you're going to have a parabola that flips down. All right, and once that's done, then you can come back and you can erase your sine function. And you have your cosecant graph. All right, so for both of these graphs, they both have a period of 2 pi. It takes 2 pi in order to graph the entire cycle of the graph. The sine function has an amplitude of 1. Remember, amplitude is the height. The height from the 0 line to the tallest point on the graph. All right, and then your cosecant graph, all right, just like I said before, also has a period of 2 pi, but it does not have an amplitude. All right, we don't talk about amplitude when we're talking about cosecant because the graph goes all the way to positive and negative infinity. Okay, So that's quickly on the sine and the cosecant. All right, so I'm going to erase this. We're going to do the same thing for cosine and for secant. All right, so let's go ahead and we'll start with cosine. All right, so we'll draw a graph. We'll mark off the same 5 tick marks. So we have one at 0. We have the next one at pi over 2. The next one at pi. The next one at 3 pi over 2. The last one at 2 pi. Remember, your cosine graph goes up to 1 and down to -1, just like the sine graph. Remember, on cosine, you have x-intercepts at the second and the fourth points. All right, so you're going to have a 0 point here and a 0 point here. It starts up at 1. So remembering that will probably be enough for you to get a feel for what the graph looks like. Third point's going to be down at -1. Fifth point's going to be back up at 1. All right, so we connect those, and we have a picture of our cosine graph. All right, so our secant graph, remember, uses the cosine graph. Same 5 tick marks, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Since secant is 1 over cosine, we're going to have asymptotes on this graph where the cosine is equal to 0, so second and fourth. So I'm going to go ahead and do my asymptotes here at the second point and also here at the fourth point. And then what we're going to do, remember, is we're going to draw that cosine graph inside and we'll erase it later. All right, so I'm going to go ahead and sketch the cosine graph. And we're going to use that to help us graph the secant graph. All right, so in between the two asymptotes, you're going to have a parabola that flips down. All right, so that's half of it. The other part in class, what we did was we actually came back here to the left, one more tick mark. So this would be -pi over 2. We know that we would have an asymptote there because the asymptotes are at every other tick mark. And our cosine graph would come down there. And so our secant graph would come up. And we just did that because we said it was easier to draw 2 entire pieces rather than it was to draw a piece here and a piece there. All right, so we have both of our graphs for cosine and for secant. They both have a period of 2 pi. Okay, even the secant, because we're starting back at -pi over 2 and we're going to 3 pi over 2, that's still a distance of 2 pi. There's no amplitude on the secant graph, but the amplitude on the cosine graph is 1. All right, so again, you want to be sure that you can draw those two. It helps to draw them paired together like I just did. All right, and then finally we're going to look at the tangent graph and the cotangent graph. All right, so let's start with the tangent. We know that tangent is sine over cosine. So I'm going to draw a graph. I'm going to use the same 5 points that I've been looking at. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, if tangent is sine over cosine, we'll have asymptotes where cosine is equal to 0. So you should be asking yourself, where is cosine equal to 0? Remember that was happening at the second and the fourth points. And in class, what we did is we did come back one. And again, negative pi over 2 would also have an asymptote because those asymptotes are occurring at every other part of the graph or every other tick mark. All right, so now to draw the actual graph, remember that we used a point. So we said that we knew that tangent at pi over 4, okay, so pi over 4 is going to sit like right here between 0 and pi over 2. We knew that tangent at pi over 4 was going to be equal to 1. So this graph should have that point on the graph. All right, so when I draw it, remember it has this sort of S-shaped curve to it. And so I'm going to come up like this, go around, hit that point, and then come up next to that asymptote. All right, and we really only need to draw one cycle of the graph. So we could actually stop there, but we know that the graph does repeat itself over in this next section. It does exactly the same thing, and it continues in between each set of tick marks, in each set of asymptotes. Okay, so the period of that tangent graph is going to be pi, and it does not have an amplitude. All right, and then cotangent works pretty much the same way. I'm going to put my 5 tick marks on. So I've got 0, pi over 2, pi, 3 pi over 2, 2 pi. Cotangent is cosine over sine, so it's going to have asymptotes wherever sine was equal to 0. So that's going to be first, third, and fifth. All right, and then we would also have one on top of the y-axis. All right, we'll use our same point, which is the point at pi over 4. Okay, so pi over 4, again, is between 0 and pi over 2, so right here. We know that cotangent has a value of 1 at that point. So all that does is give me a point to try to go through on the graph. All right, so my cotangent graph is going to start up here, and it's going to go through that point. It's going to come through that pi over 2 and then come down. All right, and again, it's going to repeat itself here. And everywhere you have 2 asymptotes, you'll have that cotangent graph in between. All right, so again, here you're going to have a period of pi. All right, so I tried to go through this quickly. I don't know if I really succeeded. It seemed to take a while. If you have questions about anything on this first part, you need to email me, okay? So you need to come in Monday being able to graph those 6 trig functions for if I ask you to graph or ask you for an amplitude or period, be able to answer those kinds of questions for the trig functions.